Lovely people. Yeah, good morning to every one of you. Thank you for being here with me today. Notice no oxygen. Now that I'll put it on here in just a little bit because I'm going to go outside, work in the garden a little bit. You can see I'm all dressed up just for that. Um, but nonetheless, so yeah, as those who follow me know, my health appears to be like a bit of a roller coaster, up and down, up and down. I'm on the heading up phase, although I'm still going in for a heart cath in a few weeks just to see what's what's causing some of my issues. Maybe they'll find something out to do. Um, I have a lot of trust in the team that's going to do it over in Mobile, Alabama. I have to do a little traveling to get that done, but it'll be all right. Um, I wasn't terribly satisfied with the results I got last time, so when I say results, there's more than one way to do a hard cath. Okay, enough of that. This is about paradoxes and paradigms, and it's going to be a series. So stay tuned. Paradoxes and paradigms. What do they have in common? What can we gain from knowing about them and following them, and such as that? What are they? Well, quickly, there'll be more. A paradox is a set of conclusions arising from the same observation that seem to, in one way or another, counter each other. Excuse me, I have an itchy nose today. Anyway, so paradoxes seem to counter each other intuitively, but yet, if it was settled, it wouldn't be a paradox. It wouldn't. It would just be a settled issue, and there are quite few of those. A paradigm, spelled paradigm, a paradigm is not 20 cents. Well, it could be, I suppose, if you had a paradigms. But a paradigm is a standard reached by a consensus of folks who believe a certain um, outcome can be expected. Yeah. Paradigms. Should we give examples? I guess we could. I haven't really thought about that. I've written them down. So this will be totally off the cuff. Of course, that's not unusual for me. Now, a paradigm. Um, hey, let's go out on a limb here. No, let's not go out. No, that one's too far. We're not going to go there. Too obvious. Paradigm is climate change. Is it or isn't it? Well, if you happen to be among those who believe that climate change is the great evil of our day, that's a paradigm. There are others, and certainly there's other ways to fit that description. We'll get into those. A paradox would be the ability of humans to only observe part of the universe. That's kind of a stretch. The speed of light, are we all traveling at that speed of light? The fact that the speed of light cannot be measured because we don't know if it travels faster one way than the other. And there's no way to find that out because the only way we've ever measured the speed of light has to do with reflections. So, in other words, if the speed of light is one speed in one direction and another speed in the opposite direction, we would never know. We're just going to get the average. And that is a paradox. You can't do it. It's just impossible with current technology. And there are many paradoxes that cover many types of situations. But those are just too random, off the cuff, certainly not inclusive. Today we're going to specialize on a couple of them. And in future, we're going to touch on many more. I'll do the old Alex Jones, many more, whatever. There's only so many minis. I mean, maybe you could have a mini. I don't know if that would work. However, Paradox for today. Paradox. I mentioned the climate change, which is like a huge issue, but let's go a little further onto that, a little deeper dive into that one. Carbon dioxide, friend or foe? Well, let's see. Carbon dioxide is the source of all of our food, all, not some, all of our food, except for if you call water a food, I guess, yeah. I'm not going to go there. We're just going to exclude water from this. Although water has its own set of paradoxes. We'll get to them later. But for now, it starts with a plant taking in carbon dioxide, converting it to various forms of sugar, and then carbohydrates and fibers, and then ultimately through other synthesis methods, converting it into proteins and fats. And when you got fats, proteins, and carbohydrates, you pretty much got the big three on what it takes to sustain life, and then all the other smaller vitamins, minerals, and micronutrients. Okay, so without carbon dioxide, you get nothing. No life. There will be no life without carbon dioxide. Now, how much carbon dioxide? Therein, we're starting to get closer to that paradox. Current atmospheric carbon dioxide, I believe, without checking my references here, 0.4%, something like that. And in the past 100 years or so, that has increased. And probably since the Industrial Revolution, it may have doubled. What does this mean for us? Well, on the plant side, the more carbon dioxide you give a plant to a limit, the better the plant does. And some greenhouses actually pump in carbon dioxide, or they will slowly consume forms of coal, not necessarily coal, could be coke, could be charcoal, but anything that will burn carbon and produce carbon dioxide inside the greenhouse, or pump it in gas-wise. And that helps the plant because the more they get, the more they can make, but it only helps the plant while sun's shining. So in other words, no photosynthesis, carbon dioxide is actually not consumed by the plant. It's only consumed during the day. At night, the plants actually expire a bit of carbon dioxide. Now, in the daytime, while they're consuming that carbon dioxide, they're busting off that carbon to use it with the hydrogen that they're getting from water, busting the water up. So they're taking water and carbon dioxide and basically busting it atomically and reforming it into sugars. And then from there, you can build anything, all the way up to DNA and, cellular biology and humans. All right, so without carbon dioxide, you're sunk. However, like I said, carbon dioxide only helps while the sun's shining. You have photosynthesis. You make sugar. Sunlight's used for the energy. That's cool. Oxygen's released. We breathe that, and everybody's happy, right? Well, I don't know. Carbon dioxide in humans is toxic at levels above, I don't know, I'd have to check the literature on this one, but I'm going to assume a percent or two. So are we close? Yeah, well, a percent or two is close to zero. So yeah, we're always going to be close. We're not going to get anywhere near a percent in the atmosphere. It can't happen. If you got near the point where you were killing off mammals, we'd all be gone long before that. So that we're nowhere near that. And the 0.25% or 0.4%, whatever we are, is wonderful if you're a plant. Now, the plant at night does exactly the opposite. The plant at night consumes oxygen, albeit not nearly as much as it gives off in the day, to keep sustaining its life. So if you keep a plant in the dark long enough, you're going to kill it because it's not producing what it needs. But it will take in a little bit of oxygen. And when you rob that plant of oxygen at night, seal it in a bag, whatever, you'll kill it that way too. So there's this need for carbon dioxide, but then there's also a limit to what you can produce. So the question is, does carbon dioxide cause global warming? Perhaps. Certainly there's a correlation to carbon dioxide and planet temperature, as can be observed in ice cores, which is a bit of a stretch, but it appears to work. You're digging out something that hasn't seen the atmosphere, a couple miles deep in Antarctica, wherever, Greenland, the North Pole, and they can dig these cores. I don't know, they've dug them miles deep, so, and they can tell what layers, just like tree rings, what happened when, but they go back a lot further than tree rings. And so they can see the effects of various ice ages. So carbon dioxide levels go up and down with the amount of snow covering the earth and reflectivity of the earth. God knows what all else, which from that you can suggest what the temperatures probably were, and also the thickness of the rings, just like trees. So it appears that there's a correlation between the amount of CO2 and the temperature of the earth. And as the CO2 goes up, the temperature of the earth goes, oh, wait a minute, does it go up or down? Well, that's the key. It can, you can get either one. In general, it goes up. It's a blanket that is like they call the greenhouse effect. So in other words, the sunlight comes in as, say, ultraviolet, and it's bouncing off the earth, but it's not really completely bouncing off the earth. It's getting absorbed by everything and then re-emitted as a lower energy spectrum, so basically infrared, which then goes bouncing out into the atmosphere and doesn't seem to be able to make it past a lot of things that are in the atmosphere, some of which is cloud cover, waters, etc. CO2 is one of them. Apparently, there is a problem with chlorofluorocarbons, i.e. refrigerants, Teflon. Yeah, Teflon made out of that stuff. And, other gases. So where's the paradox? Well, here it is. At the level of carbon dioxide that we're currently at, it's like a green point. I wouldn't call it a tipping point, but it's favorable for plant life. Plant life is favorable for oxygen production. Oxygen production is favorable for humans. Although oxygen seems to be pretty steady at 14.7. No, that's the pressure. Sorry, wrong subject. 21%, 20 to 21%, somewhere in that neighborhood. Nitrogen being the rest, 79 to 80%. And then the small amount that's left, the 1%, probably mostly argon. But then you start going down, and in carbon dioxide, if we're at a 0.4%, we're in one of those much smaller gases. And there's a bunch of them, but they get ridiculously small in quantity. So is a 0.4% carbon dioxide enough to cause a significant reflection of infrared back to the earth, thus warming the earth? Global warming. Hard to tell. Now, AOC seems to know a lot about this, so I promise you I'm not going to defer to AOC unless it's in a superficial, sardonic way. Anyway, what I will do is suggest that we are nowhere near what one would call a problem. And what the planet's population needs right now, one of the greatest needs is, or two say, water and energy. And hey, guess what? You can get clean water from energy. So how do you make it? Lots of ways, burning coal, burning oil, burning natural gas, nuclear, solar. Uh, I mean, solar works, and there's a place for it. Wind, there's a place for it, but if you're going to depend on it to survive, you better have a lot of money that you don't need, because that stuff's expensive and it doesn't control well. In other words, you can make photovoltaic from solar panels when the sun's shining and non-cloudy and such as that. You got a limited amount, less in the winter, more in the summer. Um, if you want to run your air conditioner at night, you're going to have to find a way to store energy, take it in during the day to run it at night. Or if you have wind, well, we all know that the windmills work when the wind's blowing, which is somewhat unpredictable. I mean, maybe over a year you can predict it, but not over a day. And maybe not over a week for sure. But it's there, it can be used, it can be added to, there's no problem with adding it to, say, the grid or whatever. Do it. Now, they all have their problems. Wind, you think, oh, yeah, that's great. Yeah, there's a massive amount of birds being killed by them windmills. Under any windmill, you can see like piles of dead birds. That can't be a good thing in itself. Is it worth the electricity you get out of it? Honestly, I don't know. I don't like it. I kind of like most birds. Whenever a couple of cardinals got zapped by my electric fence I put around my pigs, that's dead cardinals, made me very, very sad. I took down the electric fence and found other ways to contain my pigs that were, let's just say, a little more friendly. And the pigs, they probably were happier too. Dead birds, bad. Disposal of windmill parts. This is incredibly hard to do. They're made out of a form of fiberglass, which does not degrade under any current method. So you will eventually have landfills bigger than we currently have because windmills don't degrade. Garbage, at least most of it, does degrade to some extent. Some of it very quickly. Now, okay, so much for wind for now. Then we go off to solar. Solar, basically, like we talked about, only when the sun shines. Might get about, and also it depends on the angle of incidence of the sun on their solar panel.